Now, I realize that the impacts, that's a pretty overwhelming truth, or converging lines of evidence to handle. And we have to realize that most of us don't want to hear that, and that we want to close that out. We don't want to hear this message. In this third part, I'm going to deal with the question, what must be done to avoid this catastrophic future? First, we need to face up to the scale of the problem. It's not only that you have these impacts, but the scale of how quickly we have to reduce CO2 emissions, carbon dioxide emissions. And to do that, I'd like to give some historical background, historical perspective of carbon dioxide reduction efforts. This comes from Nicholas Stern's the Stern Review, which is the most important, probably, analysis of climate economics. So, a historical perspective. The Soviet Union's effort, or what we know from the Soviet Union. Economic collapse in the former Soviet Union after the fall of the Berlin Wall in 1989 resulted in a decline in its greenhouse gas emissions of over 5% each year for a decade. Okay, during this period, according to Clyde Hamilton, economic activity more than halved. So 5% reduction in emissions and a 50% reduction in economic activity. Let's look to France. In the late 1970s, France invested heavily in nuclear power. Nuclear generation capacity increased 40-fold between 1977 and 2003, and emissions from the electricity and heat sector fell by 6% per year. So this massive buildup of nuclear power, emissions from electricity and heat generation fell by 6% per year. But you had this was against a background of 125% increase in electricity demand. So demand went up. So the total reduction ended up being, the reduction in total fossil fuel related emissions over the same period was less significant, 0.6% per year, because of growth in other sectors. So France, in this time, had less than 1% per year reduction in emissions because of growth in other sectors. Britain, we'll look at Britain as an example. In the 1990s, Britain moved what's called the dash for gas. That is, it moved away from coal, more towards, not entirely, but away from coal, more towards natural gas. And total greenhouse gas emissions fell by an average of 1% per year between 1990 and 2000. Okay, so what we see is that with the Soviet Union, 5% per year during economic chaos, France and Britain during economic prosperity were able to reduce 1% per year. Now let's look at what has to be done to have a 67% chance of limiting global warming to 2 degrees Celsius. So what are the emissions pathways? What needs to be done to have a 67%, a 2/3 chance of limiting global warming to 2 degrees Celsius? Well, these are peak years. You see here, these are peak years. That is, you peak emissions globally. All right, so 2011, Copenhagen Accord didn't do very well. 2011's out. Now we hope for 2015. If we peak emissions globally in 2015, we'll have to reduce emissions globally relative to 2008. We'll have to reduce emissions 5.3% per year globally. That's roughly 8 to 9% per year in the developed world, in the US and Europe, and Australia. If we peak emissions in 2020, we have to reduce emissions 9% per year globally, roughly 12 to 13% in the developed world, every year. And the reason is, you see, that CO2 lasts basically forever. It continues to heat up the planet, and so you can only have a total amount of CO2 in here. So the longer you wait, the steeper this curve has to be, such that if 2015, you're basically carbon neutral by between 2045 and 2050, and 2020, if you wait till then, you're carbon neutral around 2040. This is an enormous, enormous challenge. Now, this doesn't mean that this is impossible to do this. We looked at the historical examples, France and Britain. They weren't really operating under emergency mode, as we need to. So just because they didn't do it in the past doesn't mean it's impossible. It means that gives us an indicator on how hard this is to do. If, and this comes from Kevin Anderson and Alice Bowes, if we peak emissions in 2020, this is an excellent paper, if we peak emissions in 2020 and reduce them 3% per year, we will go to 4 degrees Celsius. So the challenge is enormous, and we see throughout in the climate impacts, we've seen what a 4 degrees Celsius world is. So the question is it possible to avoid the worst of the climate problem? We are going to have, no matter what we do, if we stop today, we're still going to have some climate disruption, as we already see. But can we avoid the irreversible climate catastrophe? Well, let's look at the potential to reduce emissions. Looking at energy efficiency, we could do that immediately. If we look at the United States, we could reduce emissions 40% by 2030 through energy efficiency alone, according to the McKinsey Global Institute and other studies. So 40% simply through energy efficiency. Then we have the potential of renewable energy sources. There is much more solar, wind, and geothermal energy available to us than we need. And here I'm focusing on those renewables. I'm not focusing on nuclear, primarily because nuclear has gotten so expensive that nuclear, and it takes many years, a decade, to get a nuclear plant up, that nuclear is less, it's going to be in the mix, but it can't be center stage. It takes too long, and it's too expensive. But that's all right, so that the renewable energies can do the trick. There's enough solar energy hits the Earth's surface in 40 minutes to power the entire world for a year. Let's look at solar energy's global potential. According to Mark Jacobson at Stanford in a recently published article in the journal Energy Policy, solar energy could produce 30 times the power needed for the entire world. So 30 times the power. If we look at the U.S. potential for solar energy, there's enough harnessable solar energy in the Southwest through concentrated solar power to meet nearly 7 times the electricity needs of the entire country. That's from a study from the Department of Energy, 2007 study. And this was report to Congress. This is an image of concentrated solar power. You have all these mirrors, and the mirrors reflect to a tower. The tower has, the new towers would have molten salts, so it's concentrated solar power. Some call it baseload power. And the molten salts would melt with extreme heat, would turn into a liquid, basically. And when you had sundown, that energy, as the molten salts solidified again, they would release energy. So you could have power for 24 hours a day, 7 days a week. They call that as long as the sun shines. So potentially 24-hour power, and evidently the Italians have one that uses this storing of the power in molten salts. So the important thing to remember here is that it's not just when the sun's shining. it would actually take 1/8 of the state of Nevada to power. If we put 1/8 of the state of Nevada, 92 miles by 92 miles of these mirrors, we could power the entire United States. And these can be built very quickly. Now let's look at wind energy. According to Mark Jacobson's new study, wind energy has the potential to produce 5 to 15 times the power needed to power the whole world. Let's look at the U.S. potential. A 1991 Department of Energy study asserted that North Dakota, Kansas, and Texas had enough harnessable wind energy to satisfy national electricity needs. With the latest technology, wind power could satisfy not only our electricity needs, but all our energy needs. We could power our electric cars on those. We get electric cars, plug them in, store the energy from wind power, could store it in our batteries. Geothermal energy, this is energy from the Earth's crust. The heat in the upper 6 miles of the Earth's crust contains around 50,000 times more energy than all the world's oil and gas reserves combined. According to Mark Jacobson, if the world moved entirely to renewable sources of energy, not including nuclear power, by 2030, this would reduce worldwide power demand by 30% and replace the need for 13,000 new or existing coal plants. Jacobson also maintains that there's an enormous economic benefit of these renewable energies. He says, building all the solar, wind, geothermal, and hydropower infrastructure, along with all the transmission lines to carry this power, would still yield a long-run net savings that would more than equal the costs. So it's a great investment. And here he's not talking about the cost of the climate catastrophe. He's just talking about energy costs. But to do that requires that we have these national transmission lines, that we build a supergrid, just like we built the highway system in the 1950s. We would build a supergrid so we could take power from the southwest and deliver it to New York City, or power from wind turbines here and deliver it all over the country. And this is not only the United States, but images of powering all of Europe from concentrated solar power from the Sahara Desert. So these plans, this is all possible. So the question becomes, when we look at the scale of the problem, we did notice that renewable energies have enormous potential. But the question is, can we meet nature's deadlines? Is it possible? Can we hope? And by hope, I don't mean optimism. Optimism is that, as I would define it here, is that all will be well. I think there's no reason to be optimistic. There is reason to hope. That is to say, by hope I mean it is possible. It is possible. It's still possible to meet nature's deadlines. And it's possible with existing technology. Humanity already possesses the fundamental scientific, technical, and industrial know-how to solve the carbon and climate problem for the next half-century. That comes from a famous paper by Pakalov and Sokolov on stabilization wedges. So the big important thing to take away here is that don't think that there's some magic technology down the road that will save us from this catastrophe. We already have the technology and we're not implementing it. We're not implementing it. Now there are several plans. So not only have the technology, there's many plans on how to do this. Lester Brown, in this wonderful book, Plan B 4.0, outlines a plan to reduce global CO2 emissions 80% by 2020 in 10 years. Mark Jacobson, the paper I've been referring to throughout this section of the lecture, has a plan to switch to 100% renewable energy by 2030. He shows that it is possible. According to Jacobson, quote, based on our findings, there are no technological or economic barriers to converting the entire world to clean, renewable energy sources, end quote. It is, according to him, quote, it is a question of whether we have the societal and political will, end quote. That is, we could do this if we wanted to. So far, what I've done is I've outlined why is the globe warming, what is global warming, is it warming? I've outlined the impacts, and I've dealt with some of the scale of the problem, and I've dealt with the potential of renewable energy sources. And that has been largely dependent upon the peer-reviewed literature, entirely actually. And now I'm going to give my own editorial for what must be done. And now this is not just me, this is a great deal of other people and other reading. Can we rely, so the question is, can we rely on our leaders and political system to do what is needed to avoid the worst of the climate catastrophe? Can we rely on them? Can I go about my life and do what I was specifically trained to do without dealing with the climate problem? I'll leave it to my leaders. Well, let's look at that. And here briefly, I'd like to give a short history of disregard of climate change warnings. It's important to remember that climate change, the science is back to the 1820s and 1850s. It's a long established science, and with lots of twists and turns. It wasn't so clear. But that carbon dioxide was a greenhouse gas we've known since 1850. But let me jump to 1957, Roger Revelle, his warning. In 1957, the eminent scientist Roger Revelle, in an interview with Time magazine, said, quote, if the blanket of CO2 produces a temperature rise of only 1 or 2 degrees, a chain of secondary effects may come into play. What he meant was feedbacks, these amplifying feedbacks. Let me continue. As the air gets warmer, seawater will get warmer too, and CO2 dissolved in it will return to the atmosphere, possibly raising the temperature enough to melt the ice caps of Antarctica and Greenland, which would flood the Earth's coastal lands, end quote. That's Roger Revelle in 1957. In 1965, President Lyndon Johnson, in response to a National Academies of Sciences report, delivered a special message to Congress in which he said, quote, this generation has altered the composition of the atmosphere on a global scale through a steady increase in carbon dioxide from the burning of fossil fuels, end quote. It's important to recognize that in 1965, climate change was a nonpartisan issue. Both Republicans and Democrats recognized it as a problem. Unfortunately, today, it's become a highly partisan issue, with most of the Republicans today, and now with the Tea Party coming into power in the House of Representatives, nearly all Republicans in the House deny climate change. And Democrats, some of the so-called blue dog Democrats, don't want to do anything about climate change. And then there's others who are quite aggressive on climate change presently. But the point is back then, it's a scientific issue. It's not a partisan political issue. But it has become in the past 15 years. Let's turn to Robert White of the National Oceanic Atmospheric Association in 1978. He was the head of NOAA. And in a report, he stated, quote, we now understand that industrial waste, such as carbon dioxide released during the burning of fossil fuels, can have consequences for climate that pose a considerable threat to future society. End quote. That's 1978. over 40 years ago. The 1979 Charney Report, that is the report by the National Academy of Sciences, summarized the state of the science and indicated that there was a consensus that increased burning of fossil fuels would eventually lead to global warming. By 1988, Jim Hansen at NASA gave testimony to Congress, the United States Senate, in which he argued, quote, with 99% confidence that he was 99% confident that the greenhouse effect has been detected and it is changing our climate now, end quote. That's 1988. In 1992, the United States, most countries of the world, including the United States, signed and ratified the United Nations Framework Convention on Climate Change, and which agreed to stabilize greenhouse gas concentrations, quote, at a level that would prevent dangerous, anthropogenic, or human-induced interference with the climate system, end quote. And in 1993, we knew, it was clear that the climate could change very rapidly. We knew about abrupt climate change. In fact, in the late 1980s, we knew that climate could shift rapidly in a century. By 1993, we realized it could shift 5 degrees Celsius in a decade. So, in light of that, we should have adopted the precautionary principle, and that is started moving off fossil fuels. But we didn't. In 1997, the Kyoto Protocol. The Kyoto Protocol was the first major, or was basically trying to bring into effect the United Nations Framework Convention. And it was a legally binding agreement to reduce carbon dioxide emissions, greenhouse gas emissions. The Kyoto Protocol was adopted in December 1997. In July 1997, the U.S. Senate, by a vote of 95-0, passed a resolution opposing any protocol that does not, 1, include binding targets and timetables for developing nations, or 2, that could result in serious harm to the economy of the United States. Al Gore signed the protocol and was integral to putting the protocol together. Al Gore signed the protocol in 1988, but Bill Clinton, President Clinton, never submitted to the Senate for ratification, precisely because they had voted 95-0 that they were going to oppose the protocol. And why did they oppose it? Well, because they wanted binding targets on China and India, and they thought that it could result, they didn't want any serious harm to the economy of the United States. But the question is, how much have developing nations contributed to the problem? China and India. Well, let's look at this historically. Remember, carbon dioxide lasts in the atmosphere for thousands of years. So we can trace the historical influence. It is true that in 2008, China became the leading emitter of carbon dioxide in the world. But if we look over here, from 1751 to 2008, cumulative emissions, historical emissions, we see that the United States is responsible for 27% of the CO2 in the atmosphere, nearly a third. China, after its meteoric rise, economic rise, still was only responsible for 9%. So we're 3 times more, have 3 times greater responsibility than China. India had 2.7% of emissions historically. So we were 10 times greater emissions historically than India. So this was ridiculous to indicate that we weren't going to do anything unless China and India did anything. And they obviously felt that that was entirely unjust. And in 1997, we had a chance to adopt the Kyoto Protocol, and maybe we could have started to move the world to renewable energy, including China to renewable energy, so that China didn't become the largest emitter in the world. But we managed to not do that. Okay, so the first reason we didn't adopt the Kyoto Protocol was that we wanted binding targets on China and India. And that was never going to happen at the Kyoto Protocol. Later on, China and India would have to have binding targets. And the second reason is that they didn't do anything that would result in grave harm to the economy. Now, what exactly is the grave harm that could result from adopting measures to avoid global warming rise of more than 2 degrees Celsius? Okay, so what is the economic harm? Let's look at this. Most economic models show that mitigation measures, so reducing CO2, would reduce global GDP 2% below the level it would otherwise reach in 2050. Some models say it could be as high as 5.5%. So it would reduce global GDP 2%. That's what most models say. Some say as high as 5.5% of GDP. Reduce it by 2050. Now, what does that mean? Let's take the highest. Let's take the worst case scenario. The gravest economic harm. This is based on models today. This means that if incomes grow, a 5.5% reduction by 2050 means that if incomes grow at the anticipated 1.7% per year, average incomes will double by 2047. If we adopt the most stringent measures and stabilize at 2 degrees Celsius, that means that saving the planet, that average incomes would not double in 2047, rather they would double in 2050. So to save the planet means that average incomes would be delayed. The doubling of average incomes would be delayed 3 years on the worst case economic scenarios. But if we accept the more typical 2% estimates, we see that means, so most models say 2% reduction in GDP below the level it would otherwise reach by 2050. That means that we would not have our incomes double in 2047. Rather, we would have to wait 1 year, a 1-year delay, the grave economic harm. So we could see that that was really bogus. And it's important to note that the estimates of what happens now, so the economic case is totally for climate change. If we do nothing, Nicholas Stern, his Stern review maintains that we would lose 30% GDP. Some models say lower than that, 8% GDP. So there's a large range, but Nicholas Stern is highly distinguished, his most influential climate model probably in the world, puts it as 30% GDP. So the point is that we cannot really rely on our leaders just to do the right thing here. And we recognize that right now we did not get climate legislation. We got climate legislation through the House of Representatives in 2009 by a 9-vote margin, largely on political and party lines. Democrats, blue dog Democrats and Republicans, or conservative Democrats and Republicans voting against it, and the other Democrats voting for it. And we got it through the House of Representatives, and it was never taken up in the Senate. This is in 2009. While President Obama has done more than any other president in history to work towards renewable energy, and created more renewable energy initiatives than anyone else, President Obama never pushed this. He took up health care instead of climate change. He was told by Al Gore that if he took up climate change first in a private meeting, according to Eric Pooley, that if he took up health care and didn't take up climate change, that the Copenhagen Accord would fail. And it did fail. Now, to Obama's credit, he did rescue the Copenhagen Accord to a certain extent, but the damage had been done. Because the largest historical emitter, the United States, by 3 times, hadn't done anything, that the rest of the world wasn't going to move. So the United States, since 1997, for 13 years, has been holding back the rest of the world. Not only did Congress not pass climate legislation, but they also enacted some very bad policies. It might have been in good faith, the idea of using corn as a renewable fuel, but Congress has mandated production of 15 billion gallons of corn ethanol a year. That's 1/3 of the U.S. corn crop and 15% of the world's corn supply. So 1/3 of the corn crop and 50% of the world's corn supply is being burnt in our cars. And we saw earlier how we have record food prices, and so you've now set up a competition between, as Lester Brown says it, a competition between the 800 million people in the world who have cars and the 2.5 billion people who live on less than $2 a day. Once you turn a food into a fuel, that food will track oil prices, so that it'll drive the price of corn up. And this has a number of bad problems. First, once it gets really expensive, corn gets really expensive, in the third world there's a tendency to destroy forests in order to plant corn to make a profit. Well, when you destroy forests, that's going to lead to a lot more carbon dioxide, and destroys our natural carbon sink, that is, the forests draw CO2 out of the atmosphere. There's been several studies to suggest that the effect that turning food into fuel is actually worse in terms of carbon emissions because you have the resulting destruction of forests. In addition, corn ethanol is incredibly energy intensive. It takes 8 gallons of fossil fuel to produce 10 gallons of corn ethanol. So we're losing tons of energy just to do corn ethanol, and we've set up a competition between the poor and those who drive cars in the world. This policy simply has to stop in a world with climate change and food issues. Not only have we enacted a bad policy on corn ethanol, but we're also importing a great deal of our oil. I think it's nearly 10% of our oil from Canada, from Canada's tar sands. Many environmental scientists think the tar sands is the dirtiest project in the world. The tar sands oil extraction, as you can see here, takes the boreal forest, and makes it look like a wasteland, makes it look like the moon. And we're in the process now of destroying a Canadian boreal forest the size of Florida. So not only that's going to, obviously the boreal forests are very important for drawing carbon dioxide out of the air. So that's a really bad policy for the climate problem. In addition, it produces, relative to traditional oil extraction, the tar sands is very energy intensive. In fact, tar sands oil extraction produces 3 times more greenhouse gases than conventional oil extraction. In effect, if we really continue on the path of the tar sands, there is no hope for us. Not only is it devastating for the climate, but it's terrible. We're going to have water problems with climate change, and it requires, and the tar sands uses an enormous amount of water. 4 barrels of water are used for every barrel of oil. So we can see why many say this is the dirtiest project in the world. The tar sands pipelines, we can see, there's several pipelines, and this is the new proposed pipeline. There's an old pipeline from several years ago, and here's a pipeline running across here. This pipeline recently had a leak, and because of the BP oil spill in the Gulf,
people recognized that there was this pipeline that's going to go across the Ogallala Aquifer, which is the primary source of fresh water in Nebraska and an enormously important natural resource, maybe one of our great resources in this country, for all the agriculture in this area. And so citizens have protested that that this Keystone, this proposed Keystone pipeline, would come across the Ogallala Aquifer. And right now, these protests have been effective, and we're waiting to see whether the State Department deals with this, because it's coming from Canada. So right now it's still pending, but because many people, thousands of people have protested this, the State Department's reconsidering. So this policy just simply has to be stopped. The tar sands also is, not only with its climate impacts, it's unimaginably destructive. It produces, these are toxic ponds you can see from space. Canada has built one of the largest dams in the world to hold this toxic waste. And it's just the toxic waste from one tar sand operation. This results in the pollution of the groundwater and these unimaginable toxic ponds. I recommend people go Google the tar sands images, and you can see how really destructive it is. So these policies, not only is Congress not led in terms of climate policies, in terms of putting the price on carbon, but they have a corn ethanol policy that is simply not going to work, is not serious in a warming world, and a tar sands policy that is an absolute disaster for the climate crisis. So we can't rely on them. So who can we rely on? Well, we have to rely on ourselves. This saying from the elders of the Arabi, the Arizona Hopi Nation, that President Obama actually used, and others have used, the phrase, "We are the ones we have been waiting for." And that's not meant to be self-indulgent. That simply means that we have to get working ourselves. They're not going to do it unless we push them to do it. And that's often how change happens. So what this means is, how does this happen? How do we do this? Well, to do this, we need to revive democracy. People need to be informed. They need to vote. Educated people, people attending this university, absolutely have to vote. And not only vote, but start petitioning and pushing and calling our leaders. Now look at this. There is hope here. John Krosnick is a Stanford University sociology, has done the best reporting. He has a long analysis of how you do polls. And he's done the best polling on climate change. In June 2002, his poll results showed this. Showed that 74% of Americans thought that the Earth's temperature probably had been heating up over the last 100 years. He did an interesting thing. He said that if you take some polls like the Pew poll and other polls, ask, based on what you have read and heard, do you think the globe is warming? And they end up with roughly 55% of the population saying yes, based on what you read and heard. Krosnick maintains, no, you actually have to ask them their opinion, not based on what they've read and heard. This might be an indication of the confusion the press has caused. But if you ask them directly, 74% of Americans think that the temperature has probably been increasing over the past 100 years. 75% thought that human behavior was substantially responsible for any warming that has occurred. That's 75%. 75%, that's a huge majority. And 76% favored government limiting businesses' emissions of greenhouse gases. That's a huge majority of people. So that is very hopeful. The problem is that climate is not viewed as an immediate priority. In another poll Krosnick did in May of 2010, he asked the question, what do you think is the most important problem facing the country today? And no surprise, what do most people say? We have nearly 10% unemployment.
official 10% unemployment. 49% of Americans said the economy or unemployment was the most important problem facing us today. 1% said the environment or global warming. The problem is that people don't understand the urgency. People recognize it's warming, they want to do something about it. They do not recognize it as an immediate problem. They were somewhat like I was 3 years ago. I thought it was a 2050 problem. But as you can see, it's an immediate problem. Krosnick also asked, what do you think will be the most serious issue? So if it's not immediately an important issue, the next question is, what do you think will be the most important, the most serious problem facing the world in the future if nothing is done to stop it? 25% of Americans thought the environment or global warming, and 10% thought the economy was the most important issue in the future. So people recognize it's an enormously important issue in the future. They don't recognize an immediate issue, so they don't understand the problem. That is, that we have to move very quickly to reduce emissions. There's other good news. There's other reasons for hope. It is possible. There is potential for political change. Society, we talk about the climate system as a nonlinear system. You put a little bit of CO2 in the atmosphere, it creates big effects. It's nonlinear. Society is also like that. We saw this December, this January and February 2011. In Tunisia, a young man martyrs himself, or conflagrates himself, burns himself up. It creates these mass riots, these discontent. We saw how food prices played into that. There were other conditions. Tunisia, riots or demonstrations overturn the oppressive dictator. Egyptians see what happened in Tunisia. Young Egyptians have been planning for 3 years. The April 6th group have been planning for several years, at least 2 years, using Facebook and other technology to organize and to do kind of mock demonstrations without being notified by without drawing attention by the secret police. So they planned ahead. Tunisia demonstrations oust their dictator, and in Egypt they recognize this can be done. And it's unbelievable, it's just amazing. In 18 days, the Egyptian people, 250,000 demonstrators, got rid of a cruel dictator who used the secret police to suppress people, Hosni Mubarak. 18 days, and these people faced tanks and faced death in order for freedom. And in a much less stark example, a much powerful example, but just one that's important to recognize, is that people have power in this country. And recently, March of 2009, there was these reports that American AIG, this insurance agency that was their financial division was very much involved in creating the financial crisis. It was reported by the New York Times on a Saturday that the people in the financial division of AIG were going to get large bonuses. By Tuesday, Congress is in session adopting legislation to stop these bonuses. Why? Because people were ringing the phones. People were calling their leaders and saying this is an outrage. By Thursday, so one business day, okay, the Times reported on a Saturday, one business day, you had flooding the phone, the senators and representatives, staff phone lines, and by Tuesday they're drafting legislation, by Thursday they pass legislation. So if people rise up, it is possible. Let me give another example, a very powerful example in our history. The first Earth Day in 1970. And let me give you, Gaylord Nelson was the first, basically he was a senator from Wisconsin, and he was the one who devised the first Earth Day. But it's another example where if you start the process, then it can build very quickly. After 7 years, Senator Gaylord Nelson's quest to put environmental concerns on the political agenda happened with the first Earth Day. And here's his quote regarding the first Earth Day. Earth Day worked because of the spontaneous response at the grassroots level. We had neither the time nor the resources to organize 20 million demonstrators and the thousands of schools and local communities that participated. That was the remarkable thing about Earth Day. It organized itself. End quote. That is to say, it organized itself. You start the process, and boom! You can have this enormous outpouring, like we saw in Egypt. A few thousand people coming out in demonstrations. Within 18 days, you have 250,000 people. Maybe a few hundred people came out originally. We're still trying to get all the history of the Egyptian uprising. In 18 days, you depose a pretty awful dictator. So this is possible. It is possible. Here are the images from the first Earth Day. In the first Earth Day, 10% of the population demonstrated. And out of that, you got the Environmental Protection Agency, you got the Clean Water Act, and all the great environmental achievements of the 1970s. So what must be done? The market needs to tell the truth. That is, the market treats burning coal and burning oil and natural gas, most especially coal, it treats it as if it's cheap, but it's not cheap. It's not cheap for my future or the students who are listening to this. It's going to have catastrophic, highly expensive consequences. Congress needs to pass legislation, climate legislation. That is unlikely right now, but maybe in a few years. And right now, with the House of Representatives now controlled by Tea Party Republicans, it's unlikely because they've taken a very aggressive stance. They'd actually want to defund the Environmental Protection Agency, get rid of it. So Congress needs to pass legislation or allow the Environmental Protection Agency to tell the truth about burning fossil fuels. And the world is waiting on us. If we don't do this, the world, we are in big trouble. The United States absolutely has to lead. We must stop the building of new coal-fired power plants, 100 in process. Now this is actually a great success story. The Sierra Club's coal campaign has gotten rid of 150 coal power plants, I forget, I think over the last 4 or 5 years. That is, not got rid of them, but have prevented them from being built. Coal is the worst. Jim Hansen at NASA says that we have to be off coal by 2030. So not only do we need to support the Sierra Club and other groups' efforts to stop the building of new coal-fired power plants. These plants last for 50 years. But we also need to stop the tar sands. Not only keep it from going across the Ogallala Aquifer, which is what people are protesting, but to keep it from coming here at all. We also need to not do any more oil exploration. Jim Hansen at NASA maintains that, so in his analysis, you would have to stop burning all coal in the world by 2030. You would have to stop the tar sands, and you could burn, he said, the rest of the oil in existing oil reservoirs, but you couldn't develop new oil. So we need to stop the development of new oil. And then I would also add, which I didn't put on here, is that we really need to do something about the corn ethanol policy with the food problems that are going to be coming our way. About burning of fossil fuels. You need to put a price on carbon. What must we at Creighton do? We need to tell the truth to others. Students need to use all this great potential. Students of mine, some of them have 700 or 500, 700, 1,000 people on their Facebook pages. Use that technology.
Use that technology to communicate the seriousness of the problem. Use that technology to organize people. We've never in the history of the world had technology like this to organize people. We need to tell the truth to others about the magnitude of the problem, the natural resources to respond to the problem, and the human resources, people power, to respond to the problem. We need to urge people to join us in pressuring our leaders. First, that has to be communicating with Congress. We see that the survey of Congress shows that it's quite effective. An in-person visit, 60% of congressional staff said that that is very effective. Contact from a person who represents many constituents, the presidents of the university, for instance, has 47% effective. It's very effective. Individualized postal letters, 44% of staff, congressional staff, said that was effective. Individualized email messages, 34%, and phone calls, 20%. Form emails and form postal letters. These have to be personal letters. They do not need to be long. You just need to communicate what you want your congressional leader to do. Eventually, that's the initial step. And then we probably need to have, like, you might not call them demonstrations, but what I would call climate walks. Large show of public support for dealing with climate change, just like we have walks for breast cancer. We can have walks for climate change to deal with the problem. A large visible sign suggesting that the public wants this. And it needs to be relentless. We need to relentlessly communicate with our congressional leaders and plan and relentlessly. As I mentioned, in Egypt, young people were, for several years, were developing, using the technology to organize, to communicate with each other, and when the conditions were right, it happened quickly. Right now, we need to develop, organize, communicate, develop community here at Creighton and in the Omaha area and in the larger Nebraska. And we need to, so that when the conditions are right, we can spark real change. Scientists suggest that in 2012 we'll probably have another record temperature year, which will have another more big impacts. This is a quote from Jim Hansen. Global warming has reached a point of a planetary emergency, end quote. So the question is, what do you do in an emergency? Right? In an emergency, you immediately act. You act effectively without delay. Several months ago, I was at a stop sign and somebody ran a stop sign. There was a bad accident in front of me. 3 other cars were there. We all got out and helped. Right? It's kind of traumatizing to see that. But we all got out and helped. And that's what we need. We need people to recognize and come out and help. And this is an image from a group in Australia during the last election. And the image speaks volumes. And the line underneath it especially. That basically, we need to change, or we will be changed. We can do it somewhat on our terms, or nature will decide for us. It's quite clear one of the great problems is that this is overwhelming to hear, this truth. And so we naturally, in some way, we want to get rid of it. We want to deny it. We don't want to deal with it. And many might hear this lecture and just want to get away from this, not think about it. It's depressing. And I've gone through that myself. The thing that's helped me is to think that what do you do in an emergency? You don't, yes, you can allow yourself, or one of I've been looking at some stuff on World War II lately. What do people do behind enemy lines? That is, you can't afford to let the overwhelming character of the situation debilitate you. And that is true here. We can't allow the overwhelming, this enormous problem to debilitate us. We can recognize that there is possible, but if we don't do anything, if we go back and don't get involved, very likely
we will move into a catastrophic future. So ultimately, we have to change, or we will be changed. And finally, closing up here, to receive information on how to get involved. So we're trying to create a community here with faculty and staff and students in order to deal with this problem. To do that, you can get, this will be an email I have to directly for this issue, and I won't flood you with emails all the time. I'll send temporary email, a few emails per semester on events. And the email is, for those who have a Creighton email address, it's climate@creighton.edu. For those who are listening to this lecture and are not part of the Creighton community, or more specifically, some might be part of the Creighton community at the parish here, or part of the Omaha community, have a connection. But it's anyone who doesn't have an email address, a Creighton email address. You can email me, it's a separate file, but you'll hear about our events, and that email is climatecrisis@creighton.edu. Finally, I will post further information, recommended readings on my website, Richard Miller in the Creighton Theology Department. And I'll pause here for a second, and you can look at the actual email address, but if you Google Richard Miller, Creighton Theology, you will find it. And then finally, I want to give credit to the photo credits for some of the images of some of the impacts. The AP photo, the Nashville flooding, was an AP photo by Mark Humphrey. The flooding of the Pakistan, the Multan flooding, is Pedro Ugarte, AFP Getty Images, it's from The Guardian. And the Brisbane, the Australia flooding was from Jonathan Wood of Getty Images. Thank you all for your time. I hope this has been helpful.